Picture this. You're walking down the sidewalk, you step off the curb, and suddenly, a car horn blares right next to you. Instantly, your eyes go wide, your stomach drops, and your heart starts pounding against your ribs. What's interesting about that moment is what you didn't do. You didn't pause to consciously calculate the threat. You never thought, I should speed up my heart right now. It happened without you even trying. This chart tracks how that reaction happens. If we follow the lines down from your brain and spinal cord, we land here, the autonomic nervous system. You can think of this as your internal autopilot. It essentially means this network runs itself without you having to give it a single thought. Looking at this bottom box, you can see what this internal motor division handles. It's wired into your smooth muscles, your heart muscle, and your glands. That means it's running your lungs, running your stomach, and your sweat glands entirely in the background. Without this automatic system, we wouldn't have the mental capacity to survive. We'd be too busy trying to manually beat our own hearts to notice the speeding car we need to dodge. To manage all these organs, this autopilot splits its duties between two halves. The first half is the sympathetic division. This is the emergency response that triggered when you heard that car horn, the classic fight or flight reaction. The second half is the parasympathetic division. Its job is the opposite. It handles the quiet, daily maintenance of the body, which is often called rest and digest. This diagram highlights a major challenge for your body. If you look closely, you'll see that both of these systems are wired into the exact same organs, but they send completely opposite commands. The sympathetic side tells the lungs to expand and the heart to speed up, while the parasympathetic side tells them to narrow and slow back down. To understand exactly how your body shifts from total panic back to calm digestion without crossing its wires, we have to look at how these two opposing systems are physically built. The process begins deep in the brain. Areas like the hypothalamus and the brainstem act as master control rooms, constantly checking the environment to decide which signals need to be sent out. This diagram shows how those signals actually reach your organs. Unlike the nerves that move your arms and legs, this system doesn't use one single long wire. Instead, it uses a two-runner relay race. The first runner is the preganglionic neuron, carrying the initial command from your CNS. But it stops at an autonomic ganglion, a relay station using chemical messengers to hand off the baton. A second runner, the postganglionic neuron, takes that baton and carries it the rest of the way. It plugs directly into the target organ to deliver the final message. Splitting the journey into two steps allows the brain to modify the signal at the relay station, giving it much more control over how your body reacts to different situations. We can see that control in action by looking at the sympathetic wiring. Notice how these nerve pathways exit strictly from the middle of the spinal cord, specifically the chest and mid-back area. In this system, that first relay runner is very short. It hits a chain of relay stations located right next to the spine. Because the relay happens so early, a single signal can fan out and hit almost every organ in your body at the same time, perfect for a body-wide emergency blast. Now, look at the parasympathetic wiring. These nerves skip the mid-back entirely. They only exit from the very top, near the brainstem, and the very bottom, at the base of the spine, near your tailbone. Here, the first relay runner goes a long distance. It doesn't stop until it gets right next to, or even inside, the specific organ it's talking to. This places the relay station exactly where the work needs to be done. This physical layout determines the function. The sympathetic system is wired for a rapid, body-wide response to help you survive a threat, while the parasympathetic system is built for precise, one organ at a time control. Let's return to that sidewalk jump scare. You realize the car wasn't honking at you, and the danger has passed. Once your brain registers the all clear, the parasympathetic system takes over. You can feel the physical shift immediately. Your heart rate begins to drop, your breathing slows down, and returns to a normal, steady pace. Deeper down, your pupils shrink back to their normal size. Blood flows away from your muscles and returns to your stomach and intestines so you can finish digesting your meal. This recovery is a vital, active process. Your body is busy repairing its tissues, storing away nutrients, and replenishing the energy you just spent during the scare. It's easy to imagine these two systems like light switches, where one has to be clicked off for the other to work. In reality, they operate through autonomic tone. As this graphic shows, it's a constant, gentle tug of war. Both sides are slightly active at the exact same time, pulling against each other. By subtly adjusting the pull on either side, your body maintains homeostasis, a state of internal balance. This lets you adapt to the minor stresses of your surroundings, second by second. Whether you are dodging a car or sleeping in your bed, your internal autopilot is constantly calculating and adjusting. It is working in the background to keep you healthy and alive without you ever having to say a word.